solve a Leetcode problem. So first of all, let's try to solve Leetcode problem 89, gray code. So after solving the gray code, we're gonna use the same idea to solve Leetcode problem 1238 because it is exactly the same problem. So let's first go to the gray code. So for the gray code is that we are giving n-bit gray code sequence. So the n-bit gray code sequence is a sequence of 2 to the power of n integers. So where every integer is in the inclusive 2 to the power of n minus 1, 0 to 2 to the power of n minus 1. The first one gonna be 0, and the next one gonna be an integer appears no more than once in the sequence. So the integer gonna appear no more than once. It means every integer gonna be unique. What about the next one? The next one, the binary representation of every pair of adjacent integers differs by exactly 1 bit. So for example, 0 to 1, it differs from 1 bit because this is 0 and this is 1. Yeah, and similarly for 1 and 3, it differs from 1 bit. Yeah, so actually for the gray code, we need to use a formula because it's going to be much easier for us to solve the problem. So the formula is going to be I with XOR I right shift 1. So for I in range 2 to the power of n minus 1. So we're going to use the left shift n. Yeah. So this is going to be the formula for us to solve the gray code problem. Yeah, because normally we can search from the internet. So what is the gray code formula, and then we're going to use this formula to produce all the possible sequences of the gray code. Now we're going to use this kind of formula to solve another problem. It's going to be a little bit harder than the gray code. Yeah. Otherwise, we have to use use some other ideas to produce such kind of sequence. It's going to be a little bit harder. But currently, let's just use this case. So now we're going to use the gray code idea to solve the problem. So I'm going to prepare a gray array. Yeah, so this problem is 1238 circular permutation in binary representation. So the only difference is that we're going to have a start. Yeah, so for the gray code problem, we don't have the start. The start is 0. But for this one, the start is 3. So we just need to find the start. Yeah, because the gray code meet all the conditions like the p0 and the p to the power of n minus 1 also differs by only 1 bit in their binary representation. So we can use the gray code property to solve the problem. Yeah. Now we just need to find the index. So gray.find with start, and then we just need to return with this index plus the gray code with something to index I. Yeah, because from here this is the last one, and from here this is the first one. We just cut it in between because this sequence is a gray code. Now we're gonna cut it from here. So we find the start index. It is I. So this is gonna be the index I. Now we cut it. This is the start. So we just put these areas at the end. Yeah. So this is a head and this is tail, and the head and the tail should be connected. So this is a tail and this is head. This is why we can connect them together. Now let me just run it and submit it to check if it works. As you can see, it passed for all testing cases. And why the gray code works? So let's just try to check one by one. So for I equal to 0. So this is I 0, and 0 right shift one place, it is still 0. So while we are using XOR, it is 0. Now let's just check 1 right shift 1, it becomes 0, and XOR, after using XOR, it becomes 0 0. It is 0, and this one 1 0, it is 1, so it becomes a 1. And let's just continue. So this is going to be a 2, and this is going to be 1 0 right shift 1, it's going to become 0 1. Yeah, Now this one going to become 3, and let's just continue to check 3. So this is 3, and the right shift it's going to become 0, 1, and then we're going to still use XOR. So 0, 1 it's going to become a 1, and 1, 1 going to become a 0. So this one going to become a 2. So in this way, actually, we can produce all those numbers, and by using the Greek code, as we can see, yeah, the only difference is that for all those numbers, so this is 0 and 0, 1, 1, 1, and 1, 0. As you can see, the only difference is there's only one bit which is different, 0, 1, and 0, 1 here, and 1, 0. So yeah, basically this problem is checking us if we remember the formula of Greek code. If we remember it, we can solve it easily. Otherwise, we have to use some other ideas to solve it. I think that's all about it. Thanks for watching. See you next time.